Problem number 6 in activity 1.3 brings us to the vertical intercept. By definition, the vertical intercept is the point where the graph of a function crosses or intercepts the vertical axis. The input value of a vertical intercept is always 0. The output variable is represented by y. The vertical intercept is referred to as the y-intercept. So question 6 says, using the table of data in problem 1 or the graph in problem 4, determine the vertical intercept, in this case the v-intercept. So I've pulled up a picture of the graph from problem 4. So remember, the definition says it's the point where the graph crosses the y-intercept. In our case, we're going to call it the v-intercept because we use the letter v for value, or where it crosses the vertical intercept. So this line is crossing, right? This blue line here is crossing the vertical axis at the point 0, 20,025. So to answer question 6, I'll put the ordered pair 0, 20,025. Now if we take a look at the table, we can also find the vertical intercept. Remember, by definition, the input value is always 0 when we're looking for the vertical intercept. So the input value of 0 corresponds to the output value of 20,025. So the ordered pair for the vertical intercept from our table would be 0, 20,025. The next question asks, what's the practical meaning of the vertical intercept in this situation? Include the units. So remember, for this problem, the input represents the age of the car, and the output represented the value of the car. Right, here's the input, and here was the output. So if the input is 0, that means the car is a brand new car. So a brand new car has a value of $20,025. And I'll just type my answer in below. Moving on to question 7, we're asked, how do we determine the value of the car in problem 1 for the given number of years of ownership? So if you remember from our original table, the original value of the car was $20,025, and the car depreciated by $1,385 each year. So we had to subtract $1,385 for every year of ownership. So for a car that was 2 years old, we would take the initial value of the car and subtract 2 times the depreciation, and that would give us the value of a car that's 2 years old. So you see I have 17,255, 2-year-old car, 17,255. And for a car that was 8 years old, we would take our initial value and subtract 8 years of depreciation. And you see we're left with $8,945. So when I look at question 7, I think the value is going to be equal to the 20,025 minus the number of years of depreciation. And I just cleaned it up a little bit here to the right to place the equation in a form that looks more recognizable to you. Part B asks us to actually sketch this graph. So let's take our calculator, and they give us a window here. It says x min is -2, x max is 16, and so on. So we're going to set our window first. So I turn my calculator on, I press the window key, and I change x min to say -2. My x max is 16. Oops, I got an error. Let me fix that. I didn't put in anything after the negative sign. Okay, so my x min is -2. My x max is 16. My y minimum, according to the book, is -500. And my y maximum is 25,000. Okay, so I've set up my window, and now we're in a graph, so press the y equals key, that -1385, or -1,385, times x here's the X key, plus the $20,025. Okay, so that's what we're going to graph. That's coming from this red box, right? Negative 1385 plus 20,025. I press graph, and there's our curve. So for part 7b, we'll just maybe sketch a copy of this graph by hand in this area here. The next question asks, how does this graph compare to your graph in problem 4? So here's the graph from our calculator, and here's the graph from problem 4. And you can see they're basically identical, right? We have the same graph. So we'll just say the graphs are identical. So question 8 says, recall that the slope of your line is m, which is negative 1,385, and the vertical intercept is the point 0, 20,025. And the book asks, how is this information contained in the equation of the line you determined in problem 7a? So first we take a look at problem 7a, and you see that we have this v equals negative 1,385n plus 20,025. And I actually rewrote the equation using y and x instead of v and n. So instead of v equals negative 1385n plus 20,025, I wrote y equals negative 1385x plus 20,025. And we go back to our question, how are these pieces contained in the original equation? Well, we see that the negative 1385 is the m in y equals mx plus b, and the 20,025 is the b in y equals mx plus b. Incidentally, this y equals mx plus b is called the slope-intercept form of the equation of the line. So these numbers are significant, and they make up the shape and the direction of this line. Example 9 asks us to identify the slope and the vertical intercept of a line whose equation is given below. I'm going to pause for a moment while you write the answers, and then I'll write the answers in after you've had a moment to complete problems A through D. These are the correct answers for problem 9, A through D. And the last definition for this section is horizontal intercept. Remember, the vertical intercept is where the line crossed the vertical axis, and the horizontal intercept is going to be the graph, the point on the graph where the line crosses the horizontal axis. So question 10 asks us to determine the horizontal intercept of the graph of a car value equation v equals negative 1,385n plus 20,025. So really, the easy way to get the horizontal intercept would be plug in the 0 value to the output and solve for the input. Okay, so plug in 0 for v and solve for n. And when we finish the algebra, we're left with n equals 14.46. So as an ordered pair, we have 14.46, comma 0. 10b asks, what's the practical significance of the horizontal intercept? Include units. So remember, the input represents number of years or the age of the car, and the output represents value. So this is really telling us that if the age of the car is 14.46 years, the value of the car will be 0.